and how it's calculated. So first we need to talk about what is exactly meant by rate of change. And rate of change is a ratio of two changing values. For example, miles per hour, because when we drive a car, we're not going to always be driving the exact same speed everywhere we go. Now our first thing is if we have a table and determining if the rate of change is constant. So this first example we have is about hockey scoring, where the number of games and the number of goals. And we want to know, is that rate of change constant? And also to be able to interpret the meaning of it. And so we're first going to start with taking a look at the steps that we need. So our first step is going to be to find the change in y and the change in x. If you recall, when we make a table, x is going to be on the left and y is going to be on the right. And so we want to look, and we're going to treat these as like a sequence. So as we go from 1 to 2 and 2 to 3, I see that I am adding 1 each time. So my change in x is plus 1. Then I look over on the right-hand side, and from 2 to 4 and 4 to 6, 2 to 4 is plus 2, and 4 to 6 is plus 2. Oops, my bad. I didn't mean to write plus 6. So plus 2. And so then our second step is going to be to take those changes and create a ratio. This delta here, which is the Greek letter for D, actually means change. So we're talking here the change in y over the change in x. Well, in our case here, our change in y is equal to 2. And our change in x is 1. So now as far as interpreting if it's constant, if all the ratios are equal, then the rate of change is constant. So in our case, our delta y over delta x, or change in y over change in x from game 1 to game 2 is 2 over 1. And for the second one, it is still 2 over 1. And once again, I made my little error here. And so 2 over 1. And so because those ratios are both the same, therefore, yes, our rate of change is constant. So then that second part is to interpret the meaning of this rate of change. And so we need to add labels to this to interpret the change. Now, the nice part about a table is that our labels are right there in the table. So what this means is 2 goals, because we're looking at y first, over 1 game, because x is second. So if you wanted to rewrite that as 2 goals per, which would be a slash, game, that would be perfectly okay. So now let's take a look at 2 more examples. And I'm going to go ahead and put a screen up here so that way we can look at one at a time. Here we're taking a look at fuel economy. And when I take a look here, from 1 to 3, that's plus 2. From 3 to 5, that's plus 2. And from 5 to 7, that's plus 2. Well, that's helpful that those are the same for starters, although they don't always have to be. Here, from 25 to 80, that's plus 55. From 80 to 140, that's plus 60. And from 140 to 190, that's plus 50. So when I look here, my ratio here is 55 over 2. Then I have 60 over 2, which does simplify to 30 over 1. And then I have 50 over 2, which simplifies to 25 over 1. When I look at these 3 ratios, they are not the same, so we would say not constant. So now I want you to take a minute, solve this problem, pause it while you're solving it, and then come back and check. When I take a look at this, I go from 1 to 2, that's plus 1. 2 to 3, that's plus 1. 3 to 4, that's plus 1. And I look here, 3 to 8, that's plus 5. 8 to 14, that's plus 6. 14 to 16, that's plus 2. So I have ratios here of 5 over 1, 6 over 1, and 2 over 1. Obviously, they worked really hard the second hour and then slacked off that third hour. So this one again is not constant.